Okay, so hello everyone. Today we'll discuss about closures in JavaScript. Closures is a very important topic uh, to understand JavaScript better and also in the perspective of interview. It's really important. So closures. Today we'll discuss closures. But before discussing about closures, we should have a clarity about lexical scope and lexical environment or lexical environment. Because lexical scope plays a really important role in closures. Okay. So if you're not familiar with lexical scope or scope chaining, I have made a video about that, or you can see any other video. And uh, else, if you are comfortable with lexical scope, then let's just start. Okay. So, what would be the basic definition of closures in Java? Basically, closures is nothing but functions bundled with their lexical scope. Now, what does this mean? Was this not? Is it not the same thing that we discussed in the lexical scope or the scope chaining thing? It is a bit of related, but it is not exactly same. See, we'll understand it with an example. Okay. So maybe if I have a variable x, which is 1. Okay. Now I have a function which is maybe outside function, which has another, maybe can be like, which has another variable inside it, which is y, which is equal to, and this function returns another function which is maybe inside a function, and which what does it do? Basically, it console logs x plus is equals to 1. We can access x because of the scope chaining, because this function has access to all the parents or the local memory and the lexical environment of its parent function, which is this, and this has the access to its to the local memory and lexical environment of its parent, which is the global. Okay, and it also console logs right one and expected return side function. There are syntax error. Oh, sorry. I forgot the key. This word. And now over here, I will call this function outside. So it would be executed without any error. Let's just see it in the console. Um, it did not print. Why? Okay, let's just console log this whatever we get it. Uh, why it did not print anything in the console? Because what was the output of this was not the execution of this inside function, but the inside function itself. So the output would be like just everything copy of this function. This would be the output. So it's just the copy of the inside function, whatever it was just returned. It was not executed. That's why we did not see. Now, okay, maybe let's just store it in some kind of variable, maybe third function is equals to. Now, since it was returned this, so what would the third function store? It would store this this function, right? Now let me just call third function because it has a function inside it. Now I hope you understand. When I you know when I put in outside function inside this third function variable, the outside function was uh, you know erased from the memory space, right? Now third function just has access to the inside function and not these all thing outside function or why, because it was just put inside it. And what was over here? This thing. So now there is no way to access outside function because JavaScript is a synchronous language. And once you have passed the 18th line and you have put in the this function in the third function, the outside function has been erased from the uh, execution context, right? So now, if I execute third function, what do you think would be the output? Will it be an error saying y is not defined because the execution context was erased, so memory space was erased? Or will it be uh, the output, or will it be the output which would be like 2 and 3? See, if we get 2 in the console, then it is not a problem because x is still in the global scope. But when but y was in the local memory space of outside function, and when we initialized the third function with the output of the outside function, which was just the inside function, the local memory space and execution context of the outside function was is no longer existing. So the main catch is how will this y will now be executed. So let's just see if there would be an error or this out. Let's see. We get 2 and 3. How? How is this possible? Even after even after the uh, even after the uh, outside function was the execution context of outside function was no longer existing because of the synchronous nature of JavaScript. Still, we were able to access this variable. This was possible because of closures in JavaScript. Basically, over here we did not just return the function, we also returned the lexical environment of this function. Which means, what is the lexical environment of this function? The outside function is its lexical environment. So this was the thing that I was talking about. Whenever we return any function from anywhere from a function or maybe uh, the function is not only returned, it is returned with its lexical scope, which means even after a thousand line or a 10,000 line, if you try to execute this function again, it still has access to all of the variables in its lexical scope, which are the which is nothing but just the local memory of its parent and the parent's lexicon. Which means if I have let z is equals to 2, let r is equals to 5, even after maybe let's say over here I have thousands of lines. Even after thousands of lines, if I execute third function, it will still have access to z, r, y, etc. and x also, etc. And it will continue to implement. Now, I would like to so I hope this was a bit of clear to you right now. Let's just see if we try to execute it again. What would happen? See, now it is 3 and 4. Why? Let me just do this so it is a bit more clear. Just a second. So, yeah. initially x was 1 and y was 2. We executed the function and x was incremented to 2 and y was incremented to 3. Even now, this does not mean the see. Oh, this was see. It was executed, right? So it has been executed in some kind of memory space. There is some where in the memory where it is continuously being written. So we did not. Some people think that, oh, this means that I have access to y is equals to 2, which means I have access to this two variant, two thing. No, you actually have access to the memory of this variable, and if, like, initially you do plus 1, then you do not do plus 1 to this 2, but actually to the value which is stored inside the memory address of 1, which then becomes 3. Now, even after I try to again invoke it, it will continuously increment it because we have access to the this y variable's memory address. Okay, so as you can see, and this was all possible because of closures. Maybe we can try to see this using a debugger. Okay, so over here, if I put a debugger, yes, just see what local call stack local script scope. Okay, and maybe what if I put it over here? The call stack uh, let's just see what happens. Over here we have scope script call stack. So okay, maybe over here. Whenever we have closure, there comes a keyword in the this console. See, local we have y, script we have this. Okay, and what if I put it over here? Check over here, it should return function as well. Outside. Oh, I think it's showing the like keyword bouncing over. Yeah. Oh, sorry. See, over here we have this, right? Now, see, JavaScript knows that this is a closure thing. Like if you will return this, so it would return a closure. And see, over here we will have the access of y even after we have uh, even after outside function is no longer existing, we will still have access to all the variables. Now, closures are really important. Why? Because, and where are they important? Closures are important to execute currying. Currying is a concept in JavaScript where if you have n number of arguments and you do not want to pass them again and again, you can you can convert them in, the function into a nested function, and then you can avoid again and again uh, sending the same n number of arguments. It also helps in function decomposition. Uh, and yeah, I guess. and also the partial implementation of functions. So I'll also try to make a video on curry. You want watch that. Closures then help in overall in sorry. In the async world, they play a pretty important role. Let's just look it up. Uh, you yes, you will. Maintaining the state, right? State between each function call. As I told you, two was then incremented. So we did not use the state, the initial state. Yeah, yeah. See, I have see over here why I if you are familiar with object oriented programming and stuff, you would know that this is a private variable as of now, and only the methods defined inside this function can access this. Okay, so how do we implement this thing in real world? We can implement this with the help of clues. So this is important. There are also many more use cases. You can just find it on the internet. Right now, I'm just able to remember these. Implement private uh, methods and access private variables by your method. So this was about closures in JavaScript. Uh, so thank you for listening.